much time of you. Only 1 hour I take. Okay? Because I was instructed to give 1 hour lecture. Okay? If I finish early, you will be lucky. Alright? See, here, the difficult task for me is in front of me, professors are sitting. The mentors, Dr. Surya Narayan sir is there. Our mechanical engineer Shankar sir is there. Gopal Krishna Bhatt sir is there. All these people know Raman effect. But I believe some of you do not know what is Raman effect. But better to know Raman first. Therefore, they told me to tell about Raman. Why Raman has to be remembered today? Not only today, next few centuries Raman will be remembered. For this reason. See, I hope you are able to read that. The famous statement which is done by Raman on 16th of March 1928. He discovered Raman effect on 28th of February 1928. After discovery, he wanted to make it to public. Therefore, he came directly to National College, Bangalore, and he gave the evening, he gave a lecture. The first statement of his lecture is like this: I propose this evening to speak to you on a new kind of radiation or light emission from atoms and molecules. So, this made the change of Indian science scenario. From that, the Raman effect was publicized worldwide. Okay? With that statement, I thought of starting my lecture today. So these are the two important papers where he communicated this work to the world. And the second part is his lecture, a new radiation, which he gave at Central College, Bangalore. That's the second paper. First paper is the actual work published in July 7, 1928. It is published in Nature. It is a single author paper, that is C.V. Raman, and it is not easy task to convince the world about this new kind of radiation. Okay, my plan of talk will be like this. First, I speak about Sir C.V. Raman, his life and contribution to science. Then Raman effect, little bit on Raman spectroscopy basics, and historical background of radiation, vibration in molecules, Raman or higher activity, few applications, and typical Raman spectra and instrumentation I'll show you. Okay? The only qualification I have to speak about Raman is I also got the opportunity to work in Raman Research Institute for 2 months as a summer research fellow. Students, you also have opportunity. Every year, National Science Academy, the science academies of the nation, 3 academies, will call for the summer research fellowship. Please apply. You get 2 months time to work in a national institute at the government cost. They give everything for you. Food, accommodation, even some money you will get at the end of 2 months. And you will be representing the college at national level. Please apply because you have opportunity next 3 years. Final year you cannot apply. Okay? Therefore, I hope you will do that. Okay. Now, let us see. About Raman. He born on November 7, 1888 at Trichy, Tiruchanapalli. His parents were R. Chandrasekharaya and Parvati Ammal, and the father was a science teacher. He used to teach mathematics and science in a school. Later he promoted to a college, that is Presidency College. And Raman did his the schooling at one school called Scientology School at Tiruchanapalli. Later, he got a degree from Presidency College, Madras, at the age of 80. During those days, there was a scope for the promotion of the children to higher classes. If they are very intelligent, they can simply go directly to the 5th standard or 8th standard like that. That's provision was there when English government was there. Therefore, Raman could complete his degree. That time, no BSc, BE like this, or BA. It's called BA, Bachelor of Arts. Therefore, at the age of 18, he could complete his bachelor degree at President's College, Madras. And very interestingly, during his degree days itself, he wrote scientific articles. You know, articles means some experiment you have to do. The first article he wrote on diffraction of light, and he communicated to Philosophical Magazine at England, one of the famous magazines there. The small work which is done at the college level is published at the Philosophical Magazine of England. Imagine he is at the age of 18 himself, he could do that. And not only that, he was very interested in music because his mother used to play veena. You know, veena produces multiple tones and overtones. And he wrote a letter to Helmholtz. You know, Helmholtz experiment, all of you have done it, on a musical instrument, sound, resonance. So many things he did, no? And he says, the veena is one of the very important instruments which can give maximum overtones. At the age of 18 or 17, he could write a letter to Helmholtz and confront him about the musical notes. That is the geniusness of C.V. Raman. Okay, then after degree, he wanted to go to foreign country for higher studies. But during those days, there was a need to get medical certification to go to the foreign country. Doctor did not give him certificate that he is fit. They said, if you go there, you will die because of tuberculosis disease. TB was very popular disease during those days. Therefore, doctor did not permit him to go to foreign country for higher studies. Then, according to his father's wish, he wrote the famous Indian Civil Service Examination. That time it was called ICS. Now today you know that IAS examination. Remember, in IAS, lot of combinations are there. Some about 47 various posts you can apply when you go for IAS. He also wrote that examination, and he stood first in Civil Service Examination and became the prestigious Finance Department officer, that is called Assistant Accountant General at Calcutta. That was a very prestigious post at that time, highly remunerative post, and he started working there at the Calcutta. By then, he was already married at the age of 18 itself. He get married to Lokta Sundari, and both of them traveled to Calcutta, and he started working as a government officer in accounts department of English government. Okay? Now, the Raman's mind is only based on science. He was very interested to know about science. Daily basis, he wanted to do research, new learning he wanted to do. When he was going the way from his house to the office in a tanga, every day he used to see one important building. That building is called Indian Association for Cultivation of Science. This is the picture of the present building. Of course, about 100 years before, building was not there, definitely. But this building was constituted by one of the very famous person called Dr. Mahendra Sarkar. He had a dream to attract young students for his laboratory to do science work. For several years, nobody approached him. He had built a laboratory there, but Raman happened to visit that place, and he get the permission by his son called Amritlal Sarkar, who permits C.V. Raman to work in his free time, because he is already a government job. He is having a government job. He has to work in the office from 10 to 5 or 10 to 6 or so. Raman agreed to that. You know what was the kind of work Raman did? Raman started morning 5:30 9:30 morning he worked in the laboratory. After that, he finishes his morning breakfast, go to the office, work till evening 6 o'clock, again come back to the same laboratory till night 10 o'clock. He used to work there, and he worked continuously for several years there. Just imagine the interest of C.V. Raman. For 10 years, he continuously works in the same manner. At that time, very interestingly, the Vice Chancellor of Calcutta University, Sir Ashutosh Mukherjee, found interest in C.V. Raman. He could see the interest of Raman, and he definitely was knowing that Raman will do something for the science in India. Therefore, being the Vice Chancellor of the university, he had a power to appoint Sir C.V. Raman to the university as a professor. But there was a chair called Pallet Chair Professor, which is established by Tarak Nath. In great institutions, there will be endowment chairs. Great professors can be appointed on their chair, although they are retired, they will be appointed, and they are given very good salary there. But what is Raman's problem at that time? Raman did not have a doctorate degree. He was only BA and MA. For that, first Doctor of Science was awarded by Mukherjee to C.V. Raman, so that with that doctoral degree, he can be appointed as a professor in the Calcutta University. But you know what is the condition? The salary offered by the university to Raman, which is half of the government salary. The government salary, attractive salary he got as ICS officer, but as a professor he could get 50% of that. But Raman agreed to that, and he quit the government job and joined Calcutta University as a professor. Now, what is there in that? After 10 years of working, Raman could do lot of experiments with the help of a lot of students. There is K.C. Krishnan, so many Iyengars were there, Srinivasan was there. Several students worked along with Raman, and they could do the discovery. I will tell you discovery a little later. And what are the areas of Raman's work? Raman's work, particularly the scattering of light. Scattering of light, all of you know. I am visible because of the scattering of light. You are visible to me because of scattering of light. Then acoustics and musical instruments. If you look at the science papers, only instrumental work, science work is done by Raman. Nobody did it before, afterwards also nobody did it. He did work on instruments like veena, all the musical instruments, string instruments, even tabla, mridangam. Everywhere he worked, and he published papers. You could see the papers. And afterwards nobody worked on it because he has finished the work, whatever is required to be done with that. Okay? Not only that, X-ray crystallography, Raman did a lot of work. Several 2,000 within 1 year of Raman discovery, 2,000 crystals were studied with the help of Raman effect. Next, quantum theory, because there was a growing field at that time, he also contributed some might to quantum theory of light or radiation. Okay? These are the things about Raman. Just now I told you from the Raman's birth till how he worked in Indian ICS, Indian Cultivation Science Association, where he became a professor of Calcutta University and started working in the laboratory. Okay? That is about the first part of my talk. Now, why Raman was to be remembered, as I told you? What is the contribution of Raman? In 1917 itself, Raman started the journal of physics that is called Indian Journal of Physics. That was the first journal of science in India. started by Raman. Even today it was published. If you go to library, you may find it. Indian Journal of Physics. It is not easy to start a journal where he wrote for next lifetime. He wrote articles in that journal. You can see the first picture there. The first picture looks like a old camera. Earlier people, those who have seen the old camera, looks like a camera. That is a spectrometer which is designed by Raman. That is called quartz spectrograph. The one using which Raman could discover a Raman effect. Okay? Then what is more important? He started Indian Academy of Sciences, which is situated in Bangalore, in the RRI campus. You can see Indian Academy of Sciences. Even today, that is funded by the government of India, where a lot of activities are done for the progress of the science. Indian Academy of Sciences. And Raman became the first Indian director to Indian Institute of Science. Before Raman, all directors were English. Because of Raman credentials, he could become the first director of Indian Institute of Science. Why? What is the importance, you may think? What is great in that? What is great in that? He could attract people like Homi Baba, Vikram Sarabhai. These are the people attracted by Raman, and they built this new India. You know, contribution of Vikram Sarabhai, contribution of Homi Baba. If Raman was not a director, these people would have been gone to some foreign country where they could have flourished. But India would have been a poor country still. Because of these people's contribution, today we are enjoying the latest technology in India. Okay, therefore, Raman becoming the director of Indian Institute of Science is an important event. Not only that, after getting the Nobel Prize in 1930, he could get a huge amount of money. He did not spend that money for his own. He started an institute near Makepeace Circle, Bangalore. You can see Raman Research Institute, one of the pioneering institution it is. Very beautiful instruments are there. You can see the museum there, Raman's museum. Raman himself collected huge amount of crystals, beautiful crystals. I have got some photos there, I will show you those photos. And these are the greatest contribution of C.V. Raman to our country. Therefore, we need to remember him. Okay? Any questions if you want to ask, please you can ask. You can stop me. Any doubt, any clarifications? If I know, I will tell you. Alright. This one photo I thought of showing you. So the first picture is C.V. Raman with the Nobel laureates of 1930, all great people of various fields, chemistry, medicine, all those people are there. You can see the lower picture where Pandit Nehru, the Prime Minister, is also interested to see the Raman spectrum. He is demonstrating at Indian Institute of Science, and you can see some foreign people are there along with the because that is the English era. And you can see the rightmost picture. There is a picture of K.S. Krishnan. What is the importance of K.S. Krishnan? Anybody? Students? Why K.S. Krishnan has to be remembered? He is the one who could see Raman spectrum for the first time. He studied more than 80 various liquids. Not only liquids, highly purified liquids. And he is the first person to observe Raman effect. And he retired as director of Physical Research Laboratory at Delhi. He is also equally contributed to Raman effect, K.S. Krishnan. Okay, this photo also I thought of showing you. Now, what is Raman effect? Now we'll go to the second part of my talk. What is Raman effect? What is Raman effect? All of you know scattering of light. Okay, when light falls on any objects, which are the phenomena take place? Reflection takes place, diffraction takes place, Diffraction, depending on the size, diffraction may happen. A bending is what? Diffraction or diffraction. Okay, basically, you see, one is reflection, second one is absorption, third one is transmission. All other phenomena comes together. Okay, reflection, absorption, and transmission. Scattering is one type of refraction or reflection, you can say, scattering. Now, what is happening when light falls on a material? Who is responsible for bending or absorption? Who is responsible? The atoms or molecules. How atoms or molecules present in the material respond for the incident light. That matters. Based on that, you find two types of scattering. One is called elastic scattering, other one is inelastic scattering. What is elastic scattering? If photon exchange energy with the molecule, some kind of interaction takes place, atoms exchange energy with the photon. As a result, if photon is coming out, either should have extra energy or it should lose some energy. That is inelastic scattering. Okay, inelastic scattering. There is an exchange of energy between the atoms and the photons. If there is no exchange of energy, simply atom interaction comes by, no giving and taking energy. That is called elastic scattering. Raman effect comes to be the first category, that is inelastic scattering of light. When I say light, it can be any kind of light. It's electromagnetic radiation in general. Starting from gamma rays to, you can go to the radio waves, any kind of electromagnetic radiation can do the inelastic scattering. Now, it's not only that, how atoms are there, that's very important. Whether atoms are at rest, whether they are vibrating, all those matters. Therefore, Raman effect is basically because of vibration properties of the molecules when they are interacting. That we will see little later further. That is about Raman effect. I hope you understand. Raman effect is nothing but the inelastic scattering of electromagnetic radiation with atoms and molecules which are in vibrational states. Okay. Now, it is not only that. If only that much was there, Raman effect was not so popular today, so powerful tool today. Today we know that Raman effect is also due to the behavior of phonons. I hope you have heard the term phonons. Photons you heard, right? Photons. The quantum of energy, electromagnetic energy, photons, like the definition. What is phonon? Phonon, anybody? Somebody, please. What are phonons? Quantum of? Okay, that is vibration. Something is vibrating there, let us say. We measure them in terms of phonons. Alright. That also contributes for Raman effect. Okay, anyway. We don't require much details there. Now this is what I was trying to tell you in the beginning. Absorption, scattering and reflection. It's interaction of radiation with matter. So elastic scattering I told you. So here the lambda, that is lambda by 10, lambda when I say the particle size of the matter which is scattering is greater than lambda by 10, then it is called Mie scattering, the name of the person, Mie scattering. If it is less than lambda by 10, which is the Rayleigh scattering, which is normally what we observe is Rayleigh scattering. Okay. Similarly, if you go to inelastic scattering, then you have a category called Smegel. In 1920, he discovered that. Later, 1923, Compton scattering. You know, X-rays are scattered. The famous experiment of Compton effect, scattering of X-rays, which was awarded Nobel Prize again. That is also inelastic scattering. The Raman effect also comes under the same category because of Compton scattering, which was awarded Nobel Prize. Raman could sense it should be an optical analog to X-rays. My experiment should be an optical similarity of X-rays. Therefore, he could present it very nicely. He could do more work because I told you 7 years people worked on that, which was a feeble radiation. But Raman's genius is able to say that it is not a feeble fluorescence, it is a very important new phenomenon. Okay? Just look at the first 3 pair of lines. I hope you are able to see that. Are you able to see the first 3 pair of lines? Okay. See, there is in the top row you can see one. These are the 2 atoms. Okay, M1 and M2 are the masses. It's a diatomic molecule, just representation analog of a diatomic molecule, which is having some constant in between. That is, they are tied by some kind of force that is shown as K, and they can vibrate horizontally or in different ways they can vibrate depending on which mode you are talking about. And you see the first one, the ground level, you know, no, the lowest energy level we call it the ground level for any atom or electronic state. This is ground electronic state, and this is the first excited level. Okay, first excited level. Look at the first one, Rayleigh scattering. See the H nu you can see here, which is the light absorbed by the atom or electron, which is in the lower energy level, which is exciting them to some higher level, and they come back with the same amount of energy. That is, electron which is in the lower energy level absorbs energy, get excited to some higher level, and comes back to the same level. Okay, this kind of scattering is called Rayleigh scattering. Here, no energy exchange. Energy is neither lost nor gained. That is Rayleigh scattering, elastic scattering it is called. See the second one, look at this one. Here, electron is at the ground level, you absorb some photons, get excited to higher energy level. In the process, it is losing some energy so that they are able to reach to this level itself. That means what? Electron or atom absorb small part of energy. As a result, the emitted photon has less energy. I hope you are getting the point. That is called Stokes lines. Okay, Stokes lines. Stokes lines, where atom absorbs energy. There is natural phenomena. Everybody accepts it. It absorbs, no problem. What is coming out is less energy. It's accepted. That is Stokes lines. Now, very important is this anti-Stokes line, which is called Raman. Okay, look at it. Here, phenomena, something is different. See, atom is not in the ground level, it is in somewhere excited level itself. See, atom is at not ground level, it is having some energy, excited level. It is not at zero level, so it is not at zero level, it is here. It absorbs photons. And there are certain levels in some materials, of course in all materials, those are called virtual levels. Those levels exist for a small time period. They don't remain for permanently. They will be for small time duration, and they emit again. Now look at that. So this is having extra line. Length is extra. What do you mean by length is extra? It is having more energy. What does it mean? Atom did not absorb energy, but it is having some more energy by itself. It is adding that to the photon and sending back. This is a great observation. See, that is called an anti-Stokes line. That is a Raman line. Raman line. Now, why nobody observed this? That is very important to know. Why only Raman able to see? Why 70 years they took to understand that? Remember here, The atoms which are in the higher level are very, very small in number. Out of 10 to the power 7 atoms, 10 to the power means 10 million atoms, only one atom will be in the exact level. That will go up and come down with more energy. Therefore, if you look at the intensity of the Raman line, it is very, very weak. Therefore, it is called weak fluorescence. You know no fluorescence and phosphorescence? Hello? Yes. What is fluorescence? Absorption, emission, very quickly, within 10 to the power minus 8 seconds. What is phosphorescence? Absorption, emission little later. It takes more time. That is phosphorescence. People thought it is a fluorescence. Why fluorescence? Because it is very, very feeble, hardly able to see. During 1920s, there was no lasers. What light source we had? Only the electric light sources. Or either sunlight has to be focused or some lamp, sodium vapor lamp or other lamps are used. Therefore, it was not powerful or it is not easy to identify that very, very weak signal. I hope you are getting the point. Okay? Therefore, it's not easy for a common man to understand or observe that feeble spectral light. But only Raman and his team are able to do it because of continuous effort, working on that continuously. Okay. Remaining diagrams you don't see because, say again, to see this surface Raman, people took again 50 years. 1970s they were able to see that. Okay, 1970s. Again 50 years they have taken to understand this surface enhanced resonance. Okay, anyway. Now say this is what I am trying to say you earlier. Look at it. So this is the original light. Stokes lines are this, which is having less energy. Anti-Stokes lines which are shown more energy. Say the intensity I told you, intensity is weak. How weak it is? 10 to the power of minus 7 times of the incident light. So weak it is. 1 by 10 to the power 7. 110 million times weaker. Anti-Stokes line intensity weaker than Stokes lines. Symmetrically placed around Rayleigh, either side symmetrically placed. Anti-Stokes lines and Stokes lines. W to the power 4 depending on the frequency, depends on that. Then it can be polarizable. It can be polarizable properties. Selection rules are applied, different from fluorescence. All those things are there. I don't think it is required for you because selection rules for any excited level, you have a selection rules. Quantum mechanically, we say only these allowed states are possible. Excitation or emission, not possible for all the levels. Okay, that is about selection rules. So this is one diagram I thought of showing you. So this is done after the discovery of laser. You know, after discovery means laser principle stored in 1915 itself. But it was done only in 1960s. Because laser is a powerful tool. Once you use laser in the place of ordinary light, and you could see such beautiful spectral lines. These are the Raman lines. What they did is, they filtered all other lights, written over here, they filtered all lights except that particular wavelength. Therefore, very good, intense Raman spectral light can be seen, but it was done only after 1970s. Today, you can see the Raman light with the naked eye. You know why? Because laser source is used. Correct? If you don't have to wait for hours together to get the spectrum, as soon as you switch on, you get the spectrum. Okay, what is the importance of Raman here? How you could conclude? That's also I will tell you. Say they worked more than 80 various liquids. All people thought that the scattering is due to some impurity present in the liquid. All types of liquids, starting from water to alcohol, toluene, benzene, all standard liquids they do. Everybody thought that scattering is due to the impurity present in the liquid, and they purified the liquid several hundred times. The best quality liquid they could get. Then also they could see the feeble light. Okay, then also they could see the feeble light. And they extended to some more liquids, and they generalized it. Generalized means what? All the liquids, it is true. All the liquids. Because Raman is an important property of every element. Every substance can show the particular Raman spectrum. Only after concluding that they could do it. Moreover, Raman did not have powerful light source, I told. What did he do is, he concentrated sunlight using a telescope camera, telescope lens. He used an 8-inch telescope lens to concentrate the sunlight. Now you know the powerful light you get using a convex lens, he could concentrate the light. Because of that, something like feeble light you could see. Feeble means a weak light. And they confirmed it is true for all the liquids after studying for more than 80 liquids. And what is the time duration they have taken? Nearly 7 years. Various people did the work on that. Finally, he could understand the new phenomenon. Okay? So what I am saying is, see the consistency of the person, see the patience of the people. Not only one, the entire group of people together. Okay? Now, what are the applications? Now, quickly I am going to finish, don't worry. Okay? Applications, just mentioning possible. In solid state physics, if you worry why I need solid state physics. Okay? No, it is useful. Solid state phenomena using Raman spectroscopy, material characterization, phase transition, pressure, temperature-induced phenomena, pressure-induced decomposition, negative thermal expansion, superconductivity. Everywhere we are using that. I am not going to the details, you don't worry, but the application is important for you as a scientist or engineer. Now, where we use Raman, that is very important. Why Raman is so popular even today, and I told you, it remain forever. Because it is used in material science. Whether it is required for engineers, material science is required? Required, because without material, no science. No science, no technology is required. Required geology, mineralogy. Suppose you go today to purchase some diamond, or suppose you want to give some gold item to go to Abarana or whichever shops are there. Earlier, what they used to do? They used to scratch it, right now, and it was hurting you always. Little gold is lost. Now nothing, no scratching. They just keep it on that box. One box is there. It will give the spectral lines. It tells you the purity of the substance. How much gold is there, how much copper is there, how much silver is there, everything tells. Accordingly, they will pay you. They can purchase or they will give the money if you are giving the gold one. That is because of Raman. Correct? If you are going for a pearl, purchasing a pearl or a gem, precious stone, how do you know that it is the original stone? That is done because of Raman. They cannot cheat you because instrument will not cheat people unless you program it to cheat. Okay? Therefore, you are able to do it because of Raman. Remember Raman when you purchase gold next time. Okay? You say, I want to see the purity of the substance. Then you are from Salam to Raman. Alright. As I told you, yeah. See, that is gemology, archaeology, petroleum industry, forensic sciences, biomedical application, pharmaceutical industry, health and safety, detection of explosives, pesticides, hazardous materials. So many examples I can give you based on this. Where will you? Of course, one or two we'll see quickly. The mineralogy, I told you, no? Mineralogy. Minerals. Look at it, some examples here. I don't know whether you are able to see. See here, aluminium silicate. Aluminium silicate give this proper line here. From that you can make out this is aluminium silicate. It will tell you which type of crystal structure is there. Atomic structure, trilithium structure, atomic structure. Same material in different phases you can find different Raman lines. Next, gemology. You see, suppose it is a glass, you will get a spectrum of this kind. American diamond spectrum of this kind. It is natural diamond. See. Exact peak. Natural diamond means you have to pay more because it gives a very prominent Raman spectrum. Is it interesting? No. If it is not interesting, you have to purchase glass, assuming that it is diamond. They will cheat you. Alright. Archaeology. How old is the material? To know the history of the samples. Various examples. These are the items which is available in the research papers which are collected and put it here. These are works by different people. Okay. Surface enhanced Raman spectroscopy. This is what I am saying. So 1 out of 10 to the power 7 atom is Raman active. Then also you are able to see Raman spectrum. Imagine 1 in 10 to the power of 7 if it is Raman active. Therefore, if you carry 1 nanogram of RDX, I challenge you, you take 1 nanogram of RDX and enter into the airport today. Within no time you will be arrested. 1 nanogram is sufficient. Not a 1 gram, nanogram is sufficient. Because they have Raman detectors there. They will immediately catch you that you will carry the RDX. Or any explosive for that matter. So here, bacteria. See the bacteria. Even bacteria show Raman spectrum. They are Raman active materials. Archaeology, I gave you example of archaeology. Then forensic science. I told you, so just you see here, trinitramine. The RDX is this material. Okay, trimethylene, trinitramine. Even very small traces of that is sufficient. TNT explosive, right? That also will be easily detected within no time because Raman is so sensitive device. Explosive, I told you, explosive. See here, explosive. Raman spectra from 0.25 milligram of TNT measured at distance of 30 meters. You see, at 30 meter, if you give 0.25 milligram of TNT, Raman spectrum can be detected in the instrument. Therefore, it is not easy to cheat you when Raman is there. Nitromethylene, this is very pakka spectrum you get. This is published in this remote sensing paper. Okay. Now, just a summary. What we have done in about 1 hour or so. It is useful, non-destructive tool for studying phonon-assisted phenomena. It is not only phonon is involved. Okay. Then characterizing materials. Various materials can be characterized precisely with crystal structure, which is the compound, which is the bond, which is the bond length. Okay, which are the elements present. Everything can be seen. Systematic changes in phonon spectrum with the particle size asymmetric broadening of shift of optical phonons also can measure. I don't know whether you study optical phonons. It was there earlier. Now I don't think it is there in physics. Resonance Raman, powerful technique to probe critical points in band structure, extensively used for our CNTs. Then gives inputs for lattice dynamic calculations for wave validity. condition of theories, unique as it serves both characterization as well as basic studies. Therefore, Raman, you study Raman, you will be recognized. I tell you, those are going for higher studies. If you know Raman, you will get a job within no time. If you know Raman effect, Raman spectroscopy, I challenge you, chemistry professors will agree with me. If you know Raman, go and say, I know Raman spectroscopy. The industries will offer job within no time. So this is our one important instrument I happen to see at VRC. They are indigenously made, okay, at VRC, and it's about maybe few nearly 1 crore maybe, because it is generated indigenous. They will construct, okay. Of course, earlier Raman did it for 200 rupees. Now it is costing crores. This is what I want to tell you. Sir C.V. Raman is the only person who could get almost all medals of the world. It may be Bharat Ratna, you know, highest honor of Indian government, Nobel, knighthood from England, Sacred medal, one of the very important medal for science, Lenin prize. Not only that, Indian government released 2 times the postage stamp, 20 paisa stamp earlier, later it was 10 rupees stamp was released in honoring Sir C.V. Raman. There is nothing like more left in India for honoring Raman. Raman was given the first Bharat Ratna along with S. Adhakrishnan and C. Rajgopalachari in 1954. The 3 eminent people are given Bharat Ratna at the same time. One is C. Rajgopalachari, other one is Adhakrishnan along with Sir C.V. Raman. That was the greatest honor given to Sir C.V. Raman. So this is what I want to conclude. Raman said, the essence of science is independent thinking, hard work, and not equipment. When I got Nobel Prize, I had spent hardly 200 rupees on my equipment. Remember, 200 rupees in 1920s. Now it may be maybe over 50 lakh or so, but still, instrument doesn't matter. If you see some other scientists also, Yugi Nagamukha, see the famous the white laser, blue laser, the inventor also said the same thing, because money will not matter. What is important is hard work, consistent work, the perseverance to sustain the pressure is more important. Okay? I said I show 1 or 2 this one. If you go to Bangalore, you see Raman Research Institute, where there is a museum, Raman Museum, where he himself preserved, collected huge amounts of materials. Now it will cost in crores, diamond pieces are there. Okay? And you can see the fluorescence, phosphorus, everything there. See, this is how different natural butterflies, Raman, he could catch them, and this is the fluorescence property, he preserves them. So the butterflies, okay? Preserved. Now they are dead, but they are the butterflies. These are the some shells he kept. So these are the various crystals he has brought. You can see here. One more. So many photos I had, but I did not bring them. So here, the veena, which is played by Raman's mother, is kept there. These are the Tabala Mridangam, which is worked by Raman. He worked on these materials or these instruments. And this is one group of crystals you can see. So same thing if you see the second diagram. I don't know whether you are able to see the fluorescence of that. When light is there, it goes, then it looks like this for us. When light is switched off, they are all glowing like this. This is the Raman's collection. If you go to Bangalore, please see it, enjoy it. And there is one person who will demonstrate it very beautifully, very happy to tell you about Raman and collaboration. and how we connected also tells the story. No time to tell the story, all those things. I hope my 1 hour talk to you be useful for you. If you have any questions, please ask. If I know, I will tell you. Otherwise, I will tell third answer to you. Okay? All right. Please.
You are any questions? You are any questions? Ask.
Thank you, sir, for your words of wisdom. We are indeed ready to listen about scientist C.V. Raman sir and his life and valuable description about Raman sir. Thank you, sir. Now I request Dr. Shankar sir, head of the Department Mechanical Engineering, to give up the momentum to Dr. Chandrasekhar Shri sir as a topic of our lecture on behalf of University Institute of Technology.
Trogo.
Thank you, sir. Now I request Dr. Surya sir, Professor and Head of the Department of Physics, to deliver the word of thanks.
It is my pleasure to give vote of thanks. First of all, I thank Dr. Srinivas Principal, who presided over this function. Due to his busy schedule, he went after his program. Thank you for his presence. And Dr. Chandrasekhar Shetty is a professor and head Department of Physics, 3D Center, Science Associates College, Bangalore. And we worked together for so many times during so many functions, and we gathered so many competitions together. And for last 25 years, we are having a very good relation. And today, he given Nobel talk on Nobel Prize winner, Dr. C.V. Raman. He described as he is describing for students, and I am very happy that some of the students have given the answer for his question. Therefore, first I will congratulate the students for the interest to learn this talk. Therefore, for his noble talk, I will give thanks to Dr. Chandrasekhar Shetty. We contacted Dr. Chandrasekhar Shetty. He is having a busy schedule today. But once that schedule is changed, immediately informed. I will come on that day. And hence, again I will thank Dr. Chandrasekhar Shetty for that. And I thank all the students, who given the momentum to Dr. Chandrasekhar Shetty, and all other HODs, staff members, and all the members who helped to coordinate this program, and special thanks for you students. You are here for